ask all our participants who have joined this webinar through the Teams platform to please keep your audio and video off during the entire webinar. Please make sure that your cameras are off, and also make sure that you do not unmute yourself at any time during the entire webinar. As the previous 2 days, today's webinar will also be live streamed on YouTube, and like the previous 2 days, let me once again remind you all that you can post your questions both in the Teams platform chat box as well as the YouTube chat box, and at the end of the presentation we will moderate the questions as far as possible and convey it to our speaker today so that you can get the required answers. So let us start today's technical session, the third and final technical session of the 3-day international webinar. Today's speaker is Dr. Dipankar Mondal, and Dr. Dipankar Mondal is presently associated with the Institute of Nanoscience and Technology located at Mohali, Chandigarh. And to introduce the speaker to the audience, may I request Dr. Bishwajit Majumdar, Associate Professor in the Department of Physics, A.J.C. Bose College, Kolkata. Sir, please kindly introduce the speaker to the audience for today's session.
Am I be heard?
Yes, you are audible, sir.
Yes.
Yes, sir.
So today is the ultimate day of the 3-day webinar organized by Physics Department of our college. Our invited speaker for today is Dr. Dipankar Mondal. Dr. Mondal is presently associated with the Institute of Nanoscience and Technology, which is an autonomous GST institute located at Mohali, Chandigarh as a scientist E. His current areas of interest are piezoelectric, pyroelectric, ferroelectric materials. Actually, his area of research comprises of a vast area which includes mechanical and thermal energy harvesters, non-invasive biosensors, nanofibers, nanomaterials, e-skin, probably I think also e-tongue at Jagadish, self-power electronics, etc. He is presently guiding 6 to 8 research scholars. Now, Dr. Mondal obtained his MSc degree from Jadavpur University and his MTech degree from IIT Kharagpur. In fact, a few weeks earlier, when we were talking, I came to know that he is junior to me in the same program at IIT Kharagpur. Therefore, we recapitulated and recalled some of our old memories there, our past teachers, our labs, activities in the labs, microelectronics center, etc., etc. there. Anyway, he received his PhD from Universität Cottbus, Germany, where he worked as a scientific assistant from 2005 to 2008. He had also been a postdoctoral research fellow at Kyung-hee University, South Korea. In the meantime, he had been a faculty member and worked as an assistant professor at Department of Physics, probably I think it is Engineering Physics, at Jadavpur University from 2008 to 2017. He is also presently associated with collaborative research work at Instrumentation Engineering Department of Jadavpur University with Professor Bipon Tudu and Professor Rajiv Bandyopadhyay. His name also figured in various newspapers along with them for developing a novel mask for the present COVID-19. Now today, Dr. Dipankar Mondal will be talking about piezo and triboelectric materials and their applications. The last part of his talk will include an overview of a self-powered mask for the present pandemic situation, which he along with other members of Jadavpur University have very recently developed. Now with this, we welcome Dr. Mondal and request him to carry on with his lecture. Now over to Dr. Mondal.
Thank you, Vishwajit. I should say Vishwajit. I feel more comfortable. So, and of course, all organizers, Acharya Jagadish Chandra Bose College and IQAC. So, thank you very much for giving me the opportunity for presenting some of my, ongoing research. So, and just a short corrections. Actually, I was in Jadavpur University since 2008 to 2017, November, and I was associated with very much Department of Physics, not engineering and not science. It's Jadavpur University. Yeah. So, the only physics department, they the faculty they are teaching in different engineering stream as well. So we don't have any such separate department actually. But anyway. So I was in Jadavpur University Department of Physics, and recently I joined to INST Mohali just to get more research flavor. Yeah, that's all actually. So today actually I am going to talk something about piezo and triboelectric based some applications. So you see the background of our new institute is really is a brand new institute. You can say this is the one of the dedicated DST institutes dedicated for the nanoscience and technology. And this is a very short, a overview about Chandigarh and Mohali where we are sitting. You can see a very nice, the roundabout in the middle. So without even traffic system, I like very much this planning because, and it was like post-independence, Pandit Jawaharlal Nehru, he made with some French architecture. And without even electronic traffic or lighting system, one can easily drive without any, much trouble like accident and so on. So this is very nice planning one. And the most attractive tourist, feature is this one rock garden. So this is a very interesting architecture one can find with the different rock array in such a manner and all of waste materials. They organize, the architect organized in such a way they really make some creative features. And there are some others architecture, other tourist spot as well. So out of them one natural lake is a Sugna lake. This is another place that I like very much to visit, in the evening or weekend. So with this, now let me start the talk. So actually, it is, it's like it is presuming like in next 20 years or so, like we will be like surrounded by the billions of sensors, and the sensors basically, and there is no the limitation. It will be like spreading anywhere and everywhere, like underneath the soil or already we know the fiber optics cable in around our globe. So and then whenever we talk about the sensor, most of the cases it needs a sustainable power source. So it is very much concerned. So how can we change the traditional batteries or power source? So this is almost it's impossible to make a real management. So it's a really major concern, and it's become even severe concern when we think about the healthcare sector, right? So let's say if we recall our recent, the disaster happened in West Bengal, yeah, Amphan, right? So without electricity, we can't imagine our civilizations anymore. So it became even more severe when we think about the healthcare sectors, right? There are, every monitoring the patient, it needs several devices and it eventually needs the power source. So we are heavily depending on the power source in a short. So you see, we are very much familiar with this symbol, right? Whenever we come out from the home, we always check our battery, whether it is 100% or not, right? Without mobile phone or smartphone, even we can't think our civilization anymore. And you think about these particular cases when a old person having a pacemaker, and then whenever we visit the doctors and the person having the pacemaker, doctor say, hey, একটু দামি নিন, এটা অনেকদিন চলবে, দামি pacemaker নিন. And then when we asked the patient that what about the cost, he said, sir, I have taken a very costly one, so it's a lifetime warranty. And the lifetime warranty is practically is impossible, right? So the case is that most of the cases, since it is happening for the older person, so doctors, they are very clever. They are adding the average lifetime, and they found like the 70 years and then another 7 years. So 77 years means almost you can say the end of his life. So that's why it's they say it's a lifetime warranty. Otherwise, what happened after 7 years, the patient has to replace their pacemaker. You know why? Because it contains, the power source. So that power source need to be replaced after a certain period of time. And then, so so the now recently people are thinking if we can make it sustainable, so then it will be, no need to replace it, because particularly for replacing cost is much higher than the cost of the pacemaker actually. And you can imagine for the older person, even the pain is even more severe, right? So this is all, it's one of the example in the, implantable biomedical devices that people are thinking in near future. So, so we are thinking about the sustainable power source by the means of mechanical energy sources. So here the piezoelectricity is coming into the picture. Since those people have the physics background, so we are a little bit familiar with the piezoelectricity, right? So let me give you a real example. Like, every day whenever we go to the kitchen making some tea, and we use a gas lighter, right? So, and that contain a piezoelectric crystal basically. So whenever we give a pressure, we hammer it, and then it produces an electrical spark, because there is a two electrodes separated by a distance. So one you make it spark, we hammer it, and then sparking is taking place. And then that when it comes in front of the LPG, and it is coming as a fire basically. So, and then you can imagine for sparking, it really needs several very high voltage, around kilovolt of order. So you can imagine how much small crystals in the gas lighters can give rise some sort of high voltage. So that's the basically remarkable things that we can really think of for several applications in the future. Then there are another area basically where people are thinking even how we can use our the everyday motion, or from the mechanical motion from our system, which is readily available. No need to go somewhere else. For example, blood flow and walking, finger motion. These are the all regular activities or gestures that one has to do every day. Even walking like 300 footsteps every day, everybody are doing. So this kind of mechanical energy sources readily available. No need to pay, and in order to sustain, or in order to live our things, and then one has to do all these things, right? Because these are related to the physical motion, physiological motion, for example, blood flow, breathing, and etc. And one has to, if one calculate the energy density that we are producing due to the blood flow, 0.93 watt and 0.16 watt, that is good enough to use as a useful manner. Okay, this is one of the video. For example, here you can see this particular toy we are very much familiar with, and here we placed a piezoelectric sensor here, and you can see the oscilloscope. We can see the the production of the voltage because of the small mechanical impact. Yeah? So this is our sample. So you can imagine the mechanical energy can give rise some sort of electrical energy. So it is an energy conversion process from mechanical energy to electrical energy. And there are several applications basically that people are thinking of based on these particular phenomena. It starts from the force sensor to pressure sensor to biomedical sensor, and many other systems like robotics, implantable device, and so on. And these are the recent development that people are thinking of, even smartphone and the fingerprints recognitions, even electricity from the nose. That means like electricity engineers makes power from the human respiration. So from the respiration and the airflow, one can generate the electricity. This is the catch of the news. But the thing is that like mechanical energy from the even respiration one can use for some useful manner. And another interesting thing I should mention as a physicist, this is an energy conversion process from mechanical energy to electrical energy, and it also works in the vice versa way. That means if you once apply the electrical pulse, then it is possible to generate the mechanical energy. So that is called the motor. This is the principle of motor. And another way, once we are applying the mechanical energy and we are producing the electrical energy, this is kind of generator. So it's a generator and motor work as in reversible way. So piezoelectric phenomena is also reversible process. Okay. So one is the generator, another is motor or transducers. So let us think about the what are the materials. Being a material scientist, you have to think and search what are the materials those give rise such sort of element. So one of the mostly established materials is lead jarconate titanate (PJT), very popular and it is commercially available nowadays, and it's taking the commercial marketplace. So, but the main problem with the PJT is it is a ceramics based materials, and of course since we are talking with the mechanical energy, so it is associated with the force and all pressure, and since this is made with the ceramics, so it is brittle. So long term power supply is one of the limitations here. But and another limitation is the since it contains lead, so it is a is a very much toxic and harmful for the human society, human ecosystem. So in European Commission, they almost banned the PJT for commercial use anymore. So we have to think the alternative materials as well. And in order to use we are basically, particularly in my research area, we are thinking about the cell power system for portable electronics. And the portable electronics, the requirements of power is not much. And since our device is also getting shrinkage and sinkage, so requirements of power is also getting reduced. Of course, we are adding a lot of functionality. That is a different story. But usually, if you reduce the size, then the power density requirements of the power is also less. So the low power based electronics is one of the research area basically. So here the polymer based materials, piezoelectric materials, can have a good future basically, because it is flexible and self-adaptive, and of course one can make it biocompatible, and since it is easy to easy to process, so the cost, the end user cost will be very much less. And this is one of the reasons that I survive in Jadavpur University in a little bit competitive way, because I adopt the polymer materials, and it is no need any ultra high vacuum and sophisticated techniques in order to compete with the those are like competitive groups. So one can make it in one magnetic stirrer, make a polymer solution, and then one can cast it in different temperature, and it's a no need much costly equipment. So let me summarize some of the device those we introduced particularly. So nano generator is a term is given by Professor J.L. Wang in 2006. He is a physicist in Georgia Institute of Technology, and he is the inventor who shows in the nanoscale, basically if you make a nanostructure materials, and then nano Newton kind of force can be possible to detect. So that's, and he named the device name as the nano generator. So we are the people, we then start work on based on his observation, and this paper was published in Science in 2006. And then we introduced several nano generators, for example, self-pole PVDF film. I will discuss what is PVDF, but why I mentioned the self-fold terminology. This is one of the terminology again I adopted in order to survive in Jadavpur University, because there was no high electric field machine by which I can apply the electric field. Because in order to get the piezoelectricity, one has to align the dipole. I will discuss this, but that time I didn't have that scope. So I adopt the self-pole technique. And then another is the electrode base. So what is electrode? If you deliberately make the pore, you see in the right side image, and then you can make the electrode. So if you then apply high electric field, then each pore acts as in like macroscopic dipoles. So this is another kind of materials. Another is a plasmonic nanogenerator. If you use some plasmonic materials like gold and silver nanoparticles into the polymer matrix, then we can also functionalize or use the plasmonic energy in addition to the mechanical energy as well. And then one electrospark fiber-based nanogenerator. Here we produce the nano fibers, and then we prepare the generator. This I will list here. And then biopiezoelectric nanogenerator, as I discussed in the earlier slides, in order to make the image, think about the biocompatibility, the adverse effect in the human body. So biopiezoelectric nanogenerator is one of the research area that is. So let me discuss it molecules and excuse me, because we are physicists and we always fear about chemistry. So this is the slide I want to give very good concentration so that the students, but so it's very simple electric coefficient. So it's a very interesting materials, and this is PVDF. So the macro monomer unit is CH macromolecules, only CH2 and CH2. So two hydrogen, you can see the blue color here in the top. Yeah, these two hydrogen, and these are the fluorine, and these are black. These dots are like carbon. So this is the carbon backbone, and this is fluorine, yellow, and blue is the hydrogen. So, and since PVDF is a basically semi-crystalline polymer, what does it mean? So it contains the crystalline resin as well as the amorphous resin. So it has some regular arrangement of the atoms, that is the crystalline lamella. You can see like bricks like structure here. This is crystalline lamella, and you can see some entanglement polymer chain. These are the amorphous resin basically, and the piezoelectricity arises due to the crystallinity. So due to these bricks basically. And then the PVDF has the different crystalline polymorph. So it has different crystalline phases. For example, alpha, beta, and gamma. You see three different structures here. And this alpha phase, once you buy PVDF, this is very, very less cost-effective materials. You can buy it very easily. Like if you use a 5,000, you will get a the one bag, big bag. So 1 kilogram maybe. So you see, due to this electropositive is H plus and F is the minus, so this is act as a dipole, like two charged particles separated by distance. We can make it simplify it like this way. But this particular conformation, once you buy it, you may have this particular conformation which is non-polar. This is in chemistry, it is known as trans-Gauss conformation. No need to think much complicated things, but you can see the red arrow is here, but here is red arrow in the downwards, right? So this hydrogen is get flipped here. So this is called Gauss effect. So in order to get the net polarization, here you can see one plus positive up direction, another is a minus direction, down direction, up and minus. So it get cancelled. So net dipole moment is 0 basically. So this is known as the non-polar phase. So in order to get the piezoelectricity, one has to induce the down phase. This is a beta phase, known as the beta phase. You can see here is the very civilized manner. All hydrogen atoms are in the up directions and fluorine are in the down. So net dipole moment, all arrows, red arrows are in the up direction, and it has a resultant dipole moment greater than 0. But in this particular intermediate phase is known as the gamma phase, which is, you can see 3 arrows are up and 1 is the down. So it's can get rotate here. So this get cancelled, and still it has some polarization due to these two dipoles, and it is known as the semi-polar. And it has some other application like energy storage and so on. It is also a good phase basically. I like it. So this is triple TG. So this is we call all trans conformation. This is called the trans-Gauss conformation. This is known as triple TG. It is a gamma phase. So we adapt here in this particular talk is the electrospinning techniques, because again, why I have adopted this? These are the very simple way to make some interesting research. Let's say. So what happened? We have to collect the doctor's nozzle, the injection bala, that injection that. And then the one has to prepare the polymer solution. High voltage between this polymer jet and collector. This is grounding, and this is the positive, polarity. We are applying the high electric field between polymer jet and collector, and there is a gap here. And here we are giving the pressure. So once we are applying the pressure, what happened? Without electric field, the polymer solution, it will get, you will see the drop of flow, right? But once we apply the electric field between the collector, this is metallic collector and this is metallic tip, then what happened? Instead of drop, you will find a spray of polymer jet. This is known as the polymer jet. It needs after a critical electric field, so one can see the calor cone forming in the tip of the nozzle, and then after certain time it will get sprayed. This is a very interesting technique basically. Then once you collect the collector, and you can see the electron microscope image, you can see the macro and nanofiber. Nanofiber is dimension like 100 nanometer around diameter. Yeah, and this is again it also involves physics basically. When the strong mutual electrical repulsive force overcome overcome the forces of the surface tension, because surface tension force is there in the polymer solution. Then you can find the polymer jet, and one can collect the polymer fiber. And you see, after collection of the fiber, you can see the product which this is like a the electrospinning fiber. So, and it is very much porous, and one can make any desirable shape. For example, you see we can make it finger like shape, and if we check it through the electron microscope, you can see the fibers are randomly oriented, and it has the nano diameter, the fiber diameter around in the nanoscale. And another thing, one can also make the aligned nanofiber. You can see, so if we speed, let's say high drum collector speed, then we can make more alignment. We can also play with the polymer concentration in order to make the fiber diameter smaller and higher, because it also involves the electrostatic equation, F is equals to Q into E. So if you apply the electric field more, then you have a force more, so fibers will gets more stretch, and you will find the thinner and thinner fiber. There are some other parameters also. If we change the tip and collector distance, then also we can change the fiber morphology as well. We can also use some the porous fiber as well. So this is all about the electrospinning techniques. And so you see, the main, actually, in order to make the nano generator, one has to make the piezoelectric materials here, and then top and bottom we has to make the metallic electrode in order to collect the charges. So once we apply the the external pressure here, then the polarization it gets changed, dP by del stress, and then if we connect with the external load, then the current is basically flowing. So the main problem with the polymer nanofibers or the any organic materials, one has to make the metallic electrode, right? So otherwise, how can you make the electrode? So, and then metal, the adhesiveness of metal and polymer is not always good. So compatibility issue is there. Okay. So this is the challenge, one of the challenge that we solved in very clever way. That's why I'm concentrating on this work. You can see these photographs here in the hand. You see, this is a electrospinning fiber basically. And this is the electrospinning technique. As I mentioned, this polymer nozzle, and then we can collect it. So here we use the plate collector, you see, instead of drum, right? So here what we use the electrode. So we prepare the organic conducting electrode in a in situ electrospinning techniques. What does it mean? That means you no need to introduce the metallic electrodes afterwards. So once you do the electrospinning, that means top and bottom electrode is there. So what we use the PVDF is the polymer that I mentioned as in the middle layer, and the outer layer we use FeCl3 with the PVDF solution. Why use FeCl3? Because it acts as an oxidant. Then what we did, you see this schematic. Then after this, the FeCl3 top and bottom layers. So, and then we pass through the solvent vapor polymerization techniques. That means if we apply the 60 degrees centigrade around temperature, and if we make it the closed container, and then what happened after certain period of time, the E dot, and we put a little bit of P dot, that is the monomer of P dot. You see, the organic conducting electrode is the P dot. This is very interesting. Since the discovery of the Nobel Prize in conducting electrode, the people has aligned to use the organic electronics, and this is the one of the candidate that one can think of to use as like metal electrode. It is polymer, but it has the metallic characteristics. So its conductivity is like 1 into 10 to the power 3 Siemens per centimeter. So whereas copper, like 600 into 10 to the power 3 Siemens per centimeter. Yeah. So, but it is a conducting polymer. Okay. So then after vapor phase polymerization, you can see this is the after polymerization, the all fibers are getting coated with the P dot. So we have a like a PVDF in the middle, and then outside we have a PVDF with P dot coating. And here also PVDF and P dot coating. So we have 3-layer structure. In active layer is PVDF only, and the outer layer is the P dot coating. Okay. So this is the technique we use, and this is you see the FTIR spectra. So you see this is a net PVDF basically. This you only concentrate on these particular peaks. No need to learn any other complicated stuff. This is the characteristics of the beta phase that I'm talking about, which is responsible for the piezoelectricity. And you see, so once we do the electrospinning, due to the stretching of the polymer chain, we can also introduce the beta phase. And since we are applying the high electric field, so it is also getting cold. What does it mean? You are applying electric field, so the all dipoles randomly oriented before application of the electric field is getting aligned in particular direction, that is the electric field direction. In physics, we know the electric dipole is aligned along the electric field after certain critical field. Okay, but if we look the p dot coated PVDF nanofibers, we can see the beta phase is still there, and this is the signature of p dot. So that means we have the electrode, but at the same time that electrode also possesses the piezoelectric phase. So we don't have any loss. Like the conducting electrode, it also contains the piezoelectricity and piezoelectric phase. So the resultant behavior is very, very interesting. This is stress strain curve in physics. In physics practical, we can calculate the Young modulus here. Young modulus is also associated with the the output energy or output voltage, since we are applying the mechanical stress. And we also familiar with the IV characteristics very much in physics. So if we apply the different stress and different pressure, you can see we can improve the current, right? So it's something happening right here. So end of the day, we have a device like this. You see the top and bottom electrode, and this is our hand. And if we impart by hand in different force amplitude or pressure amplitude, you can see 1 kilopascals here and 8 kilopascals. Then we can produce like 40 volt of current voltage. Yeah, and then the current is like around the 6 microamps order of current. Yeah, if we interchange the electrode in physics practical, we are very much customized to change the electrode change karo dekho ठीक ठाक tight ache kina etc. Very, very important for experimentalists, right? So we interchange the electrode, and we see when we give the pressure here, then we can see the positive spike, and then we release it, then we favor the negative spike, right? But once we interchange the electrode, we got the negative, like reversible behavior, right? When we like press it, we get the down one. So if we get this particular behavior, then we can see yes, our device is working fine, and it has a different polarity and so on, right? And this is the famous power curve. So where what we did, we use our nano generator here, and then external resistance we use here, and here we record the voltage. Okay, so resistance voltage versus voltage, and you see once particular resistance, the impedance is basically resonance and maximum power transform is takes place, and we get the maximum power. We know the internal resistance is equals to when the external impedance, and we can get the maximum delivery of the power. So this is very important in order to make the device. And you see there, this small mechanical impart can even light several LEDs in practice. Yeah. So now again, let us switch to the some piezoelectric materials. Those are really biocompatible. These are the example. You see the two list. One is synthetic, means you have to prepare. You have to make a film, align the dipole. So piezoelectricity, in order to get the piezoelectricity, one has to align the electric dipole. So beta phase align the electric molecule. If we talk to DNA and these are the basically the natural piezoelectric materials about where the is also another is one of the source of you see the human bone, if fracture happen, then doctors, they use the piezoelectric tissue. They implant piezoelectric tissue in order to regenerate the bone, because of the electrical stimulation due to the pressure. And then the bone get healed. This is another interesting area in biology working on. And you can see some sort of wave basically. So it is basically a periodicity is there. What is periodicity? The chuler benuni mera tinte chul diye kore na. So DNA is a double helix structure, and this is the basically collagen nanofiber. This is a triple helix structure. So অনেকটা বেনুনির মতো. So and then if we see the surface of the benuni, you can see this periodicity, and one can calculate the periodicity. This red bar is we have calculated the periodicity of the collagen nanofibers. And this is the XRD structures, and you see very nice crystalline basically materials. Of course, it is semi-crystalline, but yeah, crystallinity is there. And then this is a very strong basically spectroscopic technique, near range X-ray absorption spectroscopy. In physics, we know synchrotron radiation. So if we the accelerate the charged particle electron basically, then it radiates some sort of energy, right? Tangential. This is the principle. So accelerating charged particle circulating through a circular radius, right? And it gives rise some sort of energy tangentially, right? And that means that energy it change from soft X-ray to hard X-ray. So you have a you have a very large energy source there. So you see the photon energy in the x-axis. One can change the x-axis here, and one can measure the electron yield here. And in other words, what I can say, in the collagen is consist of nitrogen, oxygen, this kind of element, and this is basically angular dependent near range X-ray absorption spectroscopy. In short, I can say if there is a difference, you see 3 different signals is in 3 different incident angle, is meaning that it has some sort of orientation. And this particular chemical structure, you can see here again the dipoles are there basically, okay, and some interpeptide bond are connected with these dipoles. You see the plus and minus and these like dipoles. So amides one is there. This is FTIR and Raman spectroscopy that indicates this gly-XY tetrapeptide sequence, basically high proportion of amino acid in collagen fibrils. And the alignment of this dipoles basically is we found out from the angular dependent near edge X-ray absorption spectroscopy. You can see the 3 different basically pi to carbon oxygen pi star transition here, and here also related to CONH. So this is oxygen cage A spectra. But in short, what we can say, this is the dichromosome of amide pi star are very much prominent. So the strong degree of molecular alignment we can see around 13%, so which is good enough to get the physioelectricity. So in summary, what I can say, that is the natural source, like the fish swim bladder, and you can see the molecular dipoles are already oriented. And in order to prove that, we did a lot of spectroscopy, but the moral the things is that the molecular dipole alignment almost 13% we have achieved. This is some fundamental physics things where you can see the polarization versus electric field P loop. So it's like a ferroelectric kind of nature. If we apply the electric field, as I said, the motor principle, then you can also generate the strain, the reverse or converse piezoelectricity. So since that is the first time we proved that fish swim bladder, and also later on I will show you the fish scale also has the intrinsic piezoelectricity. So that's why we did this kind of proof. Otherwise, the river, they were not agree to convince actually. And so we found the piezoelectric charge coefficient around 22 picocoulomb per Newton, converse piezoelectric coefficient around 0.028 volt meter per Newton. So this is one way, the proof of evidence that we had that fish scale or fish swim bladder poses the piezoelectricity. So this is the output characteristics curve, where you can see the voltage around 10 volt and some nanoamps order of current we have achieved. We can see we can lit up several LED if we give the different sort of pressure. The most interesting thing, we impart or we placed our sensor in different place of our feet. You see that right bottom this particular graph, and you see if we depending on the placement of pressure in leg, in the leg you have a different, you are producing pressure gradient in different places actually. All places are not you are giving the homogeneous pressure. So that's why in biomedical sector this is another interesting area for old people, those are having weight and so on, to get a body balance. In order to monitor that one, this kind of sensor are very much useful. So you see the right click or the upper click is giving the different kind of signals. So that indicates that our sensor can able to track the different type of mechanical impact as well. So these are the some news that actually from the the editorial press release it happened. You can see Jadavpur University name and then around the globe it get attracted this particular news. You can see if you put the Google like fish scale plus piezoelectricity, you can find several links around the globes. So it's really get very much highlighted around the globe basically. You can see in the some other language as well, like in German language, you can see the Fisherball from something, it's written in English, total written in German, as well as I found in Portuguese and other language as well, even in Chinese. So actually, really, we get very much popularized through this work. Then the question comes, how can you scale it up? Scale it up means how can you make a different thickness as your requirements and also size and shape, because the swim bladder and this fish scale also it has a limitation, right? So we adopted techniques where we use the gelatin, the fish scale made gelatin, and again we adopt the electrospinning techniques. You see this particular image, and you see the gelatin based the nanofiber we have produced, and this is the microscopic based way to prove it. It also posing the piezoelectricity. You see the phase hysteresis and butterfly loop. These are the indication of the piezoelectricity, and then through this device we power up our LCD screen and mobile, and we can show it can sustain it. The stability is also very good. So this is basically we scale up the process. You can see some interesting application. We placed our sensor here in the the goatees or let's say neck, and if we speak it or if we start talking, then we can monitor our voice signal as well. So we can even goatees closing and opening we can monitor. We can also monitor different type of voice signal like O, N, P, D, because it rounds and it vibrates our vocal cord differently. And our sensor was so sensitive to the external pressure that it can distinguish even the voice signal, what is, during pronunciation, pronouns of O and P. It can able to distinguish. You can see this particular curve where frequency and time and intensity is plotted. And so why this result is important? Because in this particular, the tough situation, we are thinking, because since people are getting affected through this, let's say, COVID and some other influenza signal virus, then what happened? Your vocal cord is get affected, right? So if you get up in the morning, then, whenever my mother called me, and then I said, okay, I'm fine. And I said, no, you get up late actually. Then I found really she can able to understand, and her sensor is so sensitive that she can able to track my voice from apart, that it is not regular voice. I really at that time I just wake up from the sleep. So in other words, what I want to tell you that the vocal cord vibration can be monitored through this piezoelectric signals. So in near future, even it may have a very good application in the biomedical sector, in order to detect whether the person is getting affected with influenza, or some in particular cases in other what type of influenza or affection it is maybe, right? So, and then you see some demonstration where we have shown our sensor is so sensitive, it can measure the different pulse signal, wrist pulse signal. For example, you see the normal condition, this is after running, and being a smoker this is the after smoking, right? So you see the different cases, this pulse rate is entirely different basically. So whenever we measure, and then we also validate with the commercial sensor, and it's really systematic, and we saw there is the index basically. This is called radial augmentation index. You see the P2 by P1. So P2 is this particular peak, this is wavefront, and a P2. So this two ratio is called the radial augmentation index. I really don't know what is the physical meaning of it, but I found it is entirely different in normal case as well as running and smoking. So it is not like normal is low and running is little bit high and smoking is high. You can see it here. In average is like 0.45, whereas in the normal rest condition is 0.86, and then for running is 0.86, and for smoking 0.12. So it is not like what we thought. So it is entirely different in the case of smoking. So it is really it is packetized, but there is separation, right? And we are talking with each other, right? And then the talking and also breathing, that mechanical motion can make separate contact and separate this kind of motion, right? So we can use this AC motion to DC if we apply the to make the all AC signal which is related to our physiological motion like breathing as well as the sleeping time and talking time. So this separation we can do it up and this circuit we can charge up the awareness. Okay? And then Dr. Bipan Guru and Professor Rajiv Bandyopadhyay and our Dr. Nityananda sir, they come up with the idea to use the electrocution layer because they thought, okay, if this droplet is coming into the contact to our mark, and then if you can make it really, we can destroy them through this electrocution phenomena, and so. And before and apart from these, actually, since there is also electric field in between the two triboelectric series, so there is another chance to the double protection to make it inactive, this aerosol droplet that consists of COVID virus. So you can see this is the real picture where we have used the conducting electrocution layer in the outside, and these are the triboelectric layers, and this is the engineering, the image where you can see the dimension, physical dimension. So since the triple layer is the catch, right? Triple cloth, just to minimize the porosity and some other phenomena maybe. So triple layer was the catch. So we also use the triple layer. Otherwise, two layers is enough. If we use the different porosity, we have to also think about the porosity, of course, and air permeability because the breathing is another big concern. And then, if we judicially use the electrocution layer, then it is possible to really make the triboelectric based this kind of layer because we are using basically capacitor to store the charges. Right? So so it is possible to make it electrocution phenomenon. And this is the real picture. You can see the right bottom image. This is the real after Mark's production. It is in the production mode now, and it will be like this. Okay, so the man having some electrical response in his face, basically, which is not destructive for his at all. I mean, like not city is not concerned. What I mean to say. The results that how can we choose the triboelectric series, two different cloths, let's say, so nylon, polyethylene, cotton, polyethylene, different combination we have tried, and we found the cotton and polyethylene one of the best choice to make the more voltage and current. You see the voltage and current is not small, and that's basically much, and then the power density is also high. We can also effective charge density versus time plot we also measure. And then finally, what I want to tell you that this is the roadmap of triboelectric nanogenerator, where you can see from 2020 where device and performance is like this, and then after 2027 it's like the diverging the application, and it is like limitless basically the application. So think about this one. You see the floating something in the the air, wind power kind of things, but this is not wind power. This is the power from the triboelectricity or ocean wave. This particular energy known as the blue energy given by Professor Jetelwan. You can type blue energy in the Google and you can read what is the difference from the so-called green energy basically. So this is the blue energy. He is thinking the all triboelectric ball should be floating underneath the ocean, and the anode mass, the energy will be produced, and that energy could be even flowing through the grid based. Basically, so far what I mentioned based on the self power, low power based technology, but he is dreaming of the the large scale energy like a blue energy. So with this, I want to acknowledge my team. Basically, these all people are basically from the Jadavpur University. Since I am young here, so I didn't put there any students' picture here. But these are all my favorite students. Those work in Jadavpur University day and night and come up with several crazy idea. We work together and we really contribute in the in some competitive way. And this is the team, those come up the idea with this current pandemic situation. Vipanda, who is really working hard to make the production line, is working day and night, even more than any student from anybody, I think. And this Debuda, basically, Das, Dr. Debuda with AK brilliant. It's a brilliant mind who is doing all the calculations and theoretical calculation, nice physics, he's enjoying. We are learning from him. Professor Bandyopadhyay, who are really real-time mentor and who has a energy in this particular age. Really, we should learn from him. And these are the students who are working during this lockdown situation in order to make it a realistic picture. So with this, I would like to thank the organizer and all of you for passionately nice listening the talk. And thanks for your kind attention. If any question or comment, I'm ready to take. Thank you.
Yes, thank you, Dr. Mondal. Thank you so much for that wonderful presentation. It was indeed an eye-opener how things that we learn in books can be utilized practically. And in fact, everything that we do in science finds use only when it is of real use to the society. So in your lab you are doing exactly that, so I think that's a wonderful thing, and the fact that you shared it with us is we are lucky to have you amongst us sharing your work. There was a certain slag in the YouTube connection in between, so we are waiting for questions in the YouTube chat box if we get any. Meanwhile, I would personally like to ask you, this mask that you are, which is almost like we saw a person putting that on also. I mean, how would a layman like us, we are now going to shops and buying masks that cost anywhere between 10 rupees and the N95 supposedly cost 350, somewhere 400. So what would the layman do to acquire such a mask to stay protected when it actually comes out in the market?
Yeah, see, this is a billion-dollar question. Country like India, when we work so hard and then we wait for the real future, and then I'm really, I don't feel much future a country like India. I'm very sorry to say this, but you can guess, you can see the newspaper and the similar kind of idea I found recently they implemented in Germany. Even they invented later on, like that's why we put our article in the journal Communication so that our date will be recorded in patent edition. Yeah. So we found they even did later with the not. They work later, like later than us, and they already implemented. So maybe we will buy their mask. But our in ICMR testings and also legal issues are going on. It needs the initiative from the government, of course. Without government initiation, nothing is possible. So we really need a fund, also encouragement from the government side and some other companies sector as well. But Vipanda, who is really working hard in order to make it dreams our fulfill. So let's see, let's wait for the, hope for the best. That much we can say. Otherwise, my suggestion is even those are using the mask with the valve and some blind mask in the market, it is better if somebody choose a 2 triboelectric series and they make their masks by their own. Even without triboelectrification, like the electrocution layer, it can protect it better. So like 2 layers, one has to choose like a silk and cotton. So two triboelectric layers is even somehow better than the so-called, let's say, the commercially available masks in the market. That much I can say, because recently we saw the efficacy with the 2 triboelectric series. If somebody choose, and simply they just swing it up and it can protect you better.
But I think this should be brought out to the masses much more, because with the unlock phase, people are going out normally, like when you go out on the roads on a day where there is no lockdown, you can see people everywhere, and they are wearing, most of them, especially in the markets. I see that they are wearing mostly the cheaper masks, which I don't know whether they actually do anything at all. Useless. So I mean, why don't you bring out some article in the newspaper or something where there, or there are so many news channels who keep on blabbering about everything related to this, but the usefulness. I mean, they are always talking about drink this juice, eat that chini, and have pepper and raise your immunity. But we people who are with science know that immunity cannot be raised overnight. It is a long time process. So why don't you come out to the news channels or newspapers and say this?
Yeah,
so
that's what we are doing actually. That's why Biponda and other our team, they are doing, Jadavpur team. They are trying their best. Yeah. So let's see the initiation. Actually, being Indian, we always love to buy others' product. This is our problem. I'm sorry to say this.
Dr. Mojumdar, if you have any questions for Dr. Mondal, would you like to unmute yourself and put forward your question?
Hello.
Yeah.
Yes, you are audible.
How much voltage is actually needed to destroy the COVID-19 virus? For that?
This is a very good question actually. Actually, to be honest, I'm not much familiar with this particular data. But what we can do, we can store the charge. Okay, we can store the charge in capacitor, and then we can use for the electrocution layer. So they are using a, the multiple diodes, triple diode or double diode or multiple diodes, in order to increase the voltage. I exactly don't know how much voltage is required in order to really make this phenomena happen. Actually, maybe Diponda can say about this.
And is
but
this
now this article is our under review. We are facing all the this kind of questions, and I think we will give the answer very shortly. So we have to quantify this. We are in the process.
Another question: how can we use this piezoelectric effect or triboelectric effect for cancer, for cancer detection or cancer treatment?
Maybe I saw some biological papers basically, but I'm not much familiar with the particular the findings. But I saw even hydrogen production through the piezoelectricity. If one can pinpoint to that point, or drug delivery through the cell power manner in that particular tissue. There are some reports on it, but I don't know exact answer of this.
And I just wanted to ask: is this something that you would need to recharge? I mean, will this be a chargeable device when it comes out?
Yeah, no. Actually, this is the catch. This is we call self-powered device. So self-powered device means is like you no need to charge it up, or you no need to do anything actually. Once you wear it, and then it is there. So because we are breathing, right? So this breathing cycle, we made a nice calculation that can give rise how much voltage and current. And that voltage and current is we want to use for the electrocution. That's what the Vishwajit asked basically. Very valid question. That how much power density or voltage is required actually. That's the most valid question I thought. So, but the thing is that this kind of self-power system means once you wear it, means it is there. Means no need to charge it up. That's why maybe you can see the all PPT, like personal protective equipment. Mostly people use like a kind of silk kind of device. I mean, like a what is called the cloth. So that may have some relation with the type. It is not like a drop falling on it and it's getting slipped. No. It may be related to the triboelectricity that only God knows, but that's why people have adopted that particular cross.
And what would be the longevity of the product if one starts using it?
So you see, these are all are very valid questions. But
Yeah,
this is the, for example, the cloths, right? Once I use my textile, we can use for 3 years, right? So it be very sustainable actually.
okay.
Yeah.
Okay, so if there are no more questions, then I think I'll thank the speaker once more. And that brings us to the end of the technical session today, the third technical session. And before leaving, I would like to inform the participants that the feedback links, the links for the feedback forms have been posted both in the YouTube chat box as well as the chat box in the Teams link, and they will be activated at 6 p.m. today, and they will remain active for the next 12 hours. So in order to get your e-certificates, you would have to fill in the particulars in these feedback forms, and your e-certificates will be generated and sent to your registered email in eventual time. With that, I would like to now invite Dr. Bishwajit Mojumdar once more, Associate Professor and Senior Most Professor of the Department of Physics, A.J.C. Bose College, to deliver the vote of thanks. Dr. Bishwajit Mojumdar, please over to you.
Thank you, Komika. Good evening, Honorable Speaker, respected principal, teachers and staff, participants, and my dear students. Now we have come to the end of this lively gathering. First of all, I would like to thank our principal, Dr. Purnachandra Maiti, and the college authority to give us the opportunity to organize the 3-day webinar on trends and scopes in physics. I would like to thank the IQAC team and the technical team for their active and support and their cooperation, for their active support and cooperation. On behalf of the entire organizing committee, I would like to thank our speaker, Dr. Day-3 Sarkar, Dr. Anirban Bandyopadhyay, and today Dr. Dipankar Mondal for their valuable lectures and inspiring words. On the first day, Dr. Day-3 Sarkar spoke about the COVID-19 effect on economy and the role of physics people in finance. He elaborately discussed about the economic cycle, role of central bank on strengthening economy during this period. Long-term, short-term debt cycle, etc. He also spoke about the scope of physics students for big data and the elaborately discussed about the economic cycle, the prior rich course. Our second speaker, Dr. Anirban Bandyopadhyay, discussed about temple structure of artificial or nano brain with multi-sphere and multi-clock concept. He also gave an overview of a brain modeling with sensors, motors, fibers, etc. The picture of the prototype of the artificial brain in a human structure built in his lab is fascinating. Now today, Dr. Mondal emphasized on self-powered electronics using piezoelectric effects, how piezoelectricity is generated in polymers, monomers, idea of nanogenerators. He talked about piezoelectric in living things like fish swing bladder, then application of piezoelectric in human body. He spoke about robotic hand contact electrification, triboelectric nanogenerator in COVID-19 mask, etc. So with this, thanks to all people who directly, indirectly helped us to make the event successful. Finally, I would express my heartful gratitude to all the guests and participants without whom the program couldn't have been made successful. We hope all of you have enjoyed all the 3 sessions. So thank you. Over to you, Kabul. Hello.
Sir, I'm here. Yes, sir.
হয়ে গেছে? Over to you. Hello. Hello. Hello.
Sorry, I got disconnected. There was some technical difficulty at my end. So, so that brings us to the end of the 3-day international webinar, Recent Trends and Scopes in Physics. And I would like to inform the participants once more that please fill up the feedback form that you will get by clicking the link that has been posted in the chat box, both in the YouTube and the Teams platform. The link will be activated at 6 today and it will remain active for the next 12 hours. So please give in your particulars and your e-certificates will be delivered to your given registered email addresses. So thank you all once again for being with us and stay safe, stay healthy till we meet again in some other webinar in our department or maybe some other department once again. Thank you and good night.